It is a lovely and wonderful day. Welcome once again to Physics Meal, a wonderful program for all physics students, including you that is watching the program. We designed this program to make the study of physics very easy for students. We are still on machine. So far we have been looking at machine. We have looked at the basic concepts of machine. After we looked at the meaning and types of machines, we have looked at mechanical advantage, velocity ratio, and efficiency of a machine. And we generated various expressions that are necessary in carrying out calculations on machine. There is need for you to subscribe to our YouTube channel and also follow us on Facebook. Today our business is to carry out calculations in machine, in simple machines. We have a variety of questions to look at as far as the calculations in simple machine is concerned. All right, we have a question already, the first example that we want to dwell on. If you did not watch our previous videos, there is need for you to do that, because the expressions, the formula that we'll be using in these calculations, we generated them in our previous video. So there is need for you to watch that video, make notes from that video, and get all the expressions that are necessary as far as machine is concerned. All right, let's look at this question. A machine has an efficiency of 60% if the machine is required to overcome a load of 30 Newton with a force of 20 Newton. Calculate its mechanical advantage. You will recall that we usually use what we call the IC principle. Each time we are trying to carry out calculations on machine, we use the principles of IC, the principle of IC. The IC means identify, set up, explore, and execute. We need to identify the quantities given to us in the question. We set it up using appropriate symbol. Then we explore, we search for the suitable expression for the calculation, and then finally we execute. So let's apply that principle here. What and what were given to us? A machine has an efficiency. We say we are going to use it to represent efficiency. It's efficiency of 60%. If the machine is required to overcome a load, so the load is 30 Newton with a force of 20 Newton, that means that force, which is now the effort, 20 Newton, we are asked to find the mechanical advantage. Now, we know that mechanical advantage is the ratio of load to effort. So if we are looking for this man, we have several expressions where we can find it. But the one we are going to use is that MA is load over effort. You will recall that we also have that efficiency is MA, that's mechanical advantage over velocity ratio times 100 over 1. But we will not use this expression because we don't know the velocity ratio. So if we know velocity ratio and we know efficiency, then we can use this to find our mechanical advantage. But here we are giving only load and effort. So we're going to use this. All right, so if we now execute, mechanical advantage will give us, what's our load? 30. What's our effort? 20. And when we divide this, mechanical advantage will be 1.5. No unit. You remember that when we looked at mechanical advantage, we say it's a dimensionless quantity, it has no unit, because load is measured in Newton and the effort is also measured in Newton. All right, that's our first example. I believe it is clear. Let's take one more question. On this. Let's look at example 2. Example 2, still on calculations on simple machine. Our second example, example 2, still on simple machine. Okay, let's pick a question quickly. All right. Okay. Let's say the velocity ratio of a machine is 5 and its efficiency 75%. What effort would be needed to lift a load of 150 Newton with the machine? Oh, beautiful, beautiful. So we'll still go together on this. That's our question. Let's provide a solution to that question. Okay? Solution to this. The velocity ratio of a machine is 5, so VR is 5. That's the velocity ratio of the machine. And its efficiency is 75%. The efficiency is 75%. Now, what effort will be needed? So we are looking for effort, E, to lift a load of 150 Newton. Load 150 Newton. We are looking for this. Okay? Now, if we decide to list all the expressions that we have, we'll be able to use two or more expressions, two expressions to actually get our effort. Now, there are two expressions that are coming to my mind which we are going to use. This is why it is necessary that you watch our previous videos. Please try and do that because it will help you. The expressions we are using for these calculations, they are all in those videos. So try as much as possible to watch our previous videos. So I know that I'm looking for effort. I know that mechanical advantage is load over effort. That means if I'm going to find effort from here, I must know load and mechanical advantage. Do you see that? But here, in the equation, I don't know what mechanical advantage. So the only thing that is stopping me from finding effort using this expression is the mechanical advantage. So if I can find mechanical advantage, that means I can find my effort because I know the load. So is there a way of finding my mechanical advantage so that I will use it to find my effort? Yes, I know that E is equal to MA over VR times 100 over 1. Okay, I know the efficiency, I know velocity ratio, so I can find my mechanical advantage. If I find my mechanical advantage, I will place it here and then use the load and the mechanical advantage to find my effort. Case closed. So we look at this together. So if I'm using this now to find my mechanical advantage, my efficiency, what's my efficiency? Efficiency is 75 MA over what? Over 5, the velocity ratio times 100 over 1. I know 5 can divide this. We are left with what? MA times 20. This MA times 20 plus 75. Okay, that means MA will give me 75 over 20. Right? So if 5 should divide this, we are going to have 15. And when 5 divide this, we have what? 4. So mechanical advantage is 15 over what? Over 4. Alright, having obtained mechanical advantage, I can just use it to find my what? Effort. So if I place this 15 over 4 is equal to the load is what? The load has been given to us as 150 divided by effort. If you clear the fraction, you are going to have 15 times E is equal to 4 times 150. That means making E the subject of formula, we have 4 times 150 over 15. So E will become 40 Newton. Because when 15 divides 150, we are going to have 10. And when 10 multiplies 4, we are going to have what? We're going to have 40. All right. So far, so good. I believe that these two calculations are very clear. But if you are still finding it difficult to understand, there is need for you to watch our first video and our second video on machine so that you will list all the expressions that are involved in machine. Very, very important. All right, that's the end of this aspect of machine today, calculations in machine, we still have a lot of calculations to carry out as far as machine is concerned. 2 examples cannot be enough. Yeah, it cannot be enough for us to drive this topic home. It's not enough. So we have series of questions to consider as far as calculations in machine is concerned. But till I come your way next time, keep visiting Mathematics and Science Meal, because a meal a day will keep you healthy in mathematics. Make sure you subscribe to our channel, make sure you like our video, make sure you share our videos, and make sure you leave a comment for us. Thank you, and God bless you.